Okay, there's your know, understand, and do. Let's move on. Doing today is really just making graphs. So we'll begin with sketch one cycle. Now there are instructions, and on the understand slide it said you need to follow the instructions, otherwise you won't know how to set up your x-axis and your y-axis. Make sure you've labeled them first, and then we'll talk about the fact that we need one cycle. Well, we have to first figure out what one cycle is, but that's what the instructions are telling us here. So let's look at some numbers that appear in the equation. We've got this 3 here. The 3 is called the amplitude, and that's equal to half the distance from a minimum to a maximum, and we're talking vertical distance, so we would be measuring a distance in between this point and up here and this point down here. So that little vertical part of the t measures the distance from the top of the function to the bottom of the function, from the mins to the maxes. Same thing here. And it'll depend on what the y-axis says, otherwise we wouldn't be able to tell from the picture exactly what it was. Back up to our function here, we've got another number in the function, and it's the 2 sitting right here, and that's called the frequency. So you can read those directly from the function. Now, it's the frequency that is of importance to us when we start out the problem, because the frequency will tell us how to set up this x-axis in conjunction with the instructions. The frequency is equal to 2. If I asked you that, you just tell me the frequency is 2. It's whatever number is sitting there. However, we need to calculate something called the period. The period of the function, by definition, is where the first cycle will end. And if we know what the period is, and it tells us to sketch one cycle, then we'll be sketching at the end of that first period. So let's calculate the period. There was a simple formula for you to remember under the know column. It's 2 pi over the frequency. Well, in this case, our frequency is 2. 2 pi over 2 is equal to pi, so our period for this function is pi. Pi is the end of the first cycle. We're supposed to sketch one cycle, so we're going to start sketching the x-axis at 0, and we are going to keep going out to pi. So let me choose 2 4 blocks, 2 4 blocks, 2 4 blocks, and 2 another 4 blocks. And since I only have to sketch one cycle here, I'm going to label this pi. If that's pi, then in the middle here is pi over 2. And you could get fancy with your fractions. I could call this 1 pi over 2. I can call that 2 pi over 2. And that'll work for me. You don't have to label every single mark on your x-axis. You have to label the 0 and label at least 2 more so I know where you are. And now this is a cosine, so we're going to plot those all-important points on the cosine. I'm going to plot a point somewhere up here. Now the somewhere up here I could actually label afterwards for these. I could just go up 5 blocks and put a dot. At the end I can go up 5 blocks and put a dot. In the middle I can come down 1, 2, 3, 4, 5 blocks and put a dot. I know at the first quarter I'm on the x-axis, at the third quarter I'm on the x-axis, and now I've got those 5 all-important dots, and I can take my pen and connect as best I can. Remember, there's curvature here. These pieces are kind of easy when you have an entire curve under the axis. It looks a little bit like a V. I might want to change that if I were working with my pencil on a piece of paper. And back up to the top. It's a little bit more difficult to write with this pen and be very precise about it. So let me try just a little bit more curvature in there. Remember that when you draw this green curve, it ought to be able to pass a vertical line test reasonably well because it is a function. And so the last piece of this, I labeled my x-axis properly, but I haven't labeled my y-axis yet. And it's as easy as this. If I know the amplitude is 3, well, that's half the distance from this point down to here. Okay, we look at where our mins are, we look at where our maxes are. If it's half the distance, we know the entire distance is 6. That means this point has to be 3, this spot has to be -3. So you can just put that amplitude on the graph after the fact and you'll be fine there, as long as you're using the same number of boxes to go up and the same number of boxes to go down. Let's take a look at a second trig function. This one we're going to use. That's the same one I just did. I'm going to switch it up a little bit. I think instead for this one, instead of graphing the cosine, we'll graph the sine of 3x. Okay, so let's begin by considering the instructions. Well, this doesn't say sketch one cycle. It says sketch in a domain 0 to 2 pi. So we can begin by setting up our x-axis going from 0 to 2 pi, and I'll again count 4 blocks. And 4 blocks is a handy count as long as this number is even. But if that number is even, you might want to reconsider the 4 blocks. A lot of times that number is even, but every now and then, probably once an assignment, maybe twice an assignment, once on a test, you might get an odd number here. And if you have an odd number here, I'm going to suggest something a little bit different. For an odd number, I'm going to say take that odd number and count that number of blocks. So I'm going to count 3 blocks, and another 3 blocks, and another 3 blocks, and another 3 blocks, another 3 blocks, and another 3 blocks. Now it says I'm supposed to go from 0 to 2 pi. So if I go 1, 2, 3, 4, 5, 6, I can make this 2 pi. That means I'll make pi in the middle here. And you'll see why I'm doing that as soon as I go to calculate the period. The period of this is equal to 2 pi over the frequency, but our frequency is 3. So our period here is equal to 2 pi over 3. And now watch what I go back and do just to kind of keep you straight on the fractions here. I'll label this 3 pi over 3. I'll say this is 6 pi over 3. 6 pi over 3 reduces to 2 pi. 3 pi over 3 reduces to 1 pi. That makes this 1 pi over 3. 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, and 6 pi over 3. And I'm doing this only because the fractions are what always seems to be the toughest thing to work with, is just working with those fraction numbers. So if you have that odd number and you want to mark off 1, 2, 3, 4, 5, 6 over 3 pi, that might help you a little bit. Okay, we're drawing a sine function in this problem. We know the sine goes through the origin, that point 0, 0, that was on the understand slide, so you can take a look at that there. I'm going to put that point on the origin. And I'm supposed to sketch to 2 pi, but the first curve doesn't end at 2 pi. It's 2 pi over 3 for the period, so the first curve actually ends at 2 pi over 3, so that's where I have to put my dot. So I'm going to put, my pen is doing its own thing here. So my first cycle is actually going to stop at 2 pi over 3. My 5 important dots need, this is the start, this is the finish. I have 1 in the middle. I have 1, let's go up 3 blocks. When you have a bigger frequency, you don't want to go too high. It'll be easier to draw if you don't. As a matter of fact, I'm going to change my mind. I'm only going to go up 2 blocks. And let me go down 2 blocks. So in the first quarter, I'm going to go up 2. In the second quarter, I'm going to go down 2. And now you can see you have 1 complete sine curve, if you connect the dots with your curvature. And it stops at 2 pi over 3, and that's what the period told us it's supposed to do. Because these functions cycle, we just keep going around the London Eye. If you pay more money, you're going to stay on the ride longer, and you're just going to keep going in circles. You're not going to do anything different. Do the same thing over and over. That's what happens to the graph. It's just going to keep going, doing the same thing over and over. A starting point, a new finish point, a halfway point. In the first quarter we go up, in the third quarter we go down, and we've got our second cycle. And it does the same thing again. Starting point, finish point, a halfway point. In the first quarter we go up, and in the third quarter we go down. And again, you're working with a pencil to draw these curves, so you always have the chance to go back and erase just to clean it up a little bit. And now that we have the curves drawn, again, just consider, would somebody say that passes a function test or not? It should be reasonable. We'll label this y equals 2 sine of 3x. We got our x and our y-axis labeled. Oh, wait a minute, we don't have our y-axis labeled. We have a 0, but that's not sufficient. That amplitude of 2, we want to mark that off up here, which means we also want to mark off the -2 down here. Show you one more graph of this one. We'll talk about a cosine function. We'll go back to the cosine function. Let's take a look at the amplitude which is a distance measure, so it can never be negative. My amplitude is 3, and that's what you'd write on an answer line. You wouldn't say -3, you'd say 3. But that negative means that I'm going to be reflecting over the x-axis, so I'll have to keep that in mind as I go. This 1/2 is my frequency, and that frequency is going to be important for me to set up the x-axis, and I always want to set up the x-axis first. That's really the one that's going to be much more work than the other. So let's begin by calculating the period. The period is equal to 2 pi over the frequency. That's 2 pi over 1/2. Oh heavens, there's a fraction. We'll do a keep change flip. We'll get 4 pi. So my period is 4 pi. It says sketch in the domain 0 to 2 pi. So this is why I have to honor the instructions. I'm going to start at 0. I don't have an odd number here, so I think I'll just start using 4 blocks. 0. We'll put a tick mark here. 1, 2, 3. Put a tick mark here. Tick mark here. A tick mark here. We'll call this 2 pi. We'll call that pi. Okay, now we're going to turn our attention to the period again. This says that my first cycle will end at 4 pi. Well, here's 2 pi. 4 pi is way the heck out here off the graph, and I'm not supposed to be graphing out here. So if I'm going to be ending at 4 pi, I'm only going to see half a cycle by the time I get to 2 pi. So I'm not going to plot those 5 important points on a cosine curve. I'm only going to plot half the cosine curve. Now the cosine curve normally starts up here, but there's a minus sign there, which means every point that was up now has to be a point down. And every point that was down, that's going to be that one, now has to be a point up. Now keep in mind, I'm using 2 blocks for 1. Keep in mind that I'm only seeing, right now, I'm only seeing those 3 important points on the cosine curve. This one, and this one. However, everything has been reflected over the x-axis. So we're going to see the first one is now down. Well, the middle one is still on the x-axis. When you reflect over the x-axis, it doesn't go anywhere. And then the third one is up. And now I'm going to pick up my pencil, and with showing curvature as best I can, it's kind of tough to do this, but you don't want to pick up and create a straight line there. You want it to show some curvature. So there's your graph of y equals -3 cosine of 1/2 x. It's got an amplitude of 3, +3. It's got a frequency of 1/2. It's got a period of 4 pi. We want to be sure to label the y-axis. If I put the maximum up here, that number is a 3. If my minimum's down here, that number is a -3. That should match your amplitude. Last graph I'd like to show you is the graph of a tangent function, and we'll talk a little bit about the tangent function because it's a whole lot different than the others. Okay, so here is the function f of x is equal to the tangent of x. And the good news about the tangent function is we're not going to mess around with the amplitude or the frequency in a tangent function. The only thing that you'll be asked to graph is maybe a basic tangent function. More likely you'll be asked to recognize it. So let's talk about the all-important points on a tangent function. Well, we have a starting point, and that's 0, 0. And we have a finishing point, and that's on the x-axis at 2 pi. And we have a middle point. So far it looks a lot like the sine function. But if you remember in our trig functions unit, we had tangent doing funny things. Tangent was the one that would come up as undefined. And so there's something happening with the tangent function that doesn't happen with the others. And as you look at those blue curves, you should be able to see that behavior. This tangent function will go up forever right here at pi over 2. But hey, on the other side, it comes down forever as it's coming close to pi over 2. Well, that's what's called our asymptote. Just like we had in our rectangular hyperbolas. So the function never touches pi over 2, and that means it's undefined at pi over 2, and that's where all those undefined values came from. Also, it never touches 3 pi over 2. So when we were down at 270 degrees or 3 pi over 2, again we had undefined business going on with the tangent. So let's take a look at one more set of important points on these graphs. This value right here, 45 degrees. If you remember from your special angle table, the tangent of 45 is equal to 1. So before you start sending it off to outer space up here, you want to mark off halfway through the first quadrant. Here's our first quadrant, second quadrant, third quadrant, fourth quadrant. Halfway through the first quadrant at 45 degrees, or pi over 4, we'd be up at 1. And the same thing happens in the third quadrant. Likewise, halfway through the second quadrant, we're down at -1, and I'm using 2 blocks to represent 1 and -1 here. And again, halfway through the fourth quadrant, we're down at -1. So I think I made that tick mark just a wee bit too far. Move that dot there. Oops. So if you have to recognize this, which is likely, or draw it, which is a little less likely, but it's not difficult, as long as you have your start, finish, and middle on the x-axis, and then you've actually got 2 points up at 1, 2 points down at -1 for representing the middle of each quarter. And that would be your tangent function.